I'm excited to be here. Thanks everyone for having me today, and hope everybody's having a great day so far. So with that, I will pull up my screen here and move a couple of Zoom windows around and whatnot. All right. So yeah, we're gonna be talking about really going beyond the chatbot with event-driven agents, and I want to start off actually with a little disclaimer. Okay, and that's first off, this talk isn't going to be able to cover every aspect of creating production-ready agents. Okay. At the end of the day, we're all still learning together. We're all still figuring out what does it actually mean to have a production-ready agent. What sort of testing and QA and validation do these agents need to go through? How do we test these things, especially when they're non-deterministic, et cetera? So in many ways, I want to kind of frame this talk as a, hey, I'm actively learning and building stuff and trying out new things. And so this talk is basically, hey, here's things that I've learned recently and things that I've been thinking a lot about, but also things that Docker is thinking a lot about it as well too. We'll see a lot of the Docker AI tools and capabilities as we go throughout this as well too. But again, feedback welcome and anticipated. I'll be watching the Zoom chat and the Q&A and all that kind of stuff as well too. So if you have questions along the way, feel free to ask. So what are the things that we're going to talk about today? Okay. First off, I'm going to help set some framing of what and why of event-driven agents. What am I thinking about? What do I mean when I say event-driven agents? And then we're just going to go through an example of one. Okay. And so, yes, this particular talk is talking about using GitHub and webhooks and analyzing PRs and whatnot. And I'll talk about why I'm thinking about that particular space when we get there. But we're actually going to build the agent together here. So you'll see me write some code. I'll set up the models, set up the tools, the MCP servers, et cetera. And again, we'll iterate on that. We'll build this together. And then I'm going to wrap it up with some lessons learned. So as I went through this journey and this experience, what are some of the lessons that I learned, and what would I do differently if I were to start this particular application again? Okay. So with that, what and why of event-driven agents? Okay. Now, when we typically talk about Gen AI, we can basically break it down and define it like this. Okay. So Gen AI provides the ability for us to leverage models to create new content based on a set of input or prompts. Okay. And what this means is, yeah, I can use these models and I can give them new prompts and new inputs and new things that the model hasn't seen before. And based on the algorithms and the training of the model, it can take that new set of input and figure out, okay, based on this set of input, what do I generate? Okay. And that may be a chatbot response. It may be images. It may be code. It may be music. It could be a lot of different things. But basically, the models are basically doing predictive analysis. And I mean, it's a black box to most of us, but it's feeding off the prompts or inputs. Okay. Now, when we talk about agentic applications, the agentic applications take this a little bit step further. Okay. And agentic applications need three things. They use these models to both generate content and also figure out what steps are needed. But then they also have access to tools. And tools can provide a lot of different capabilities. Go look up information, go perform a function, a lot of different things. And we'll see some examples of that here in just a little bit. And then finally, there's the code that glues it all together. So how do we connect the models and the tools and and the code helps us do that. The code can help us have memory or do evaluations to determine, okay, are the flows working the way we expect it to, et cetera. Okay. But one of the things that's really interesting to me is when I talk to colleagues or friends or folks out in the industry or whatnot, they're like, hey, I made this agent, go run this command, and then open up your browser to localhost whatever, and there's a chat interface, and you kick off the agent with that chat interface. And I'm like, okay, that's cool, but why do I have to kick it off with a chat interface? Why do I have to have a chat bot to kick off some of these workflows? So for example, if I had one that said, hey, summarize my Jira issues and create a Notion page for me with my tasks for the day. I know it's just an arbitrary one. Why do I need a chat bot to do that? Why can't it just be an automated task that runs? Okay. And so again, when we start thinking about these agentic applications, what are different ways to kick them off or to trigger them or to launch them, whether that's time, whether that's events in our systems. What are other things that can be used to kick this off? Now, I've basically kind of coined that of going beyond the chatbot. Okay, again, what are ways that we can think beyond the chatbot? As I started looking around at various applications, I've actually noticed that there's been times in which I've seen Gen AI being used and didn't even realize that it was actually being used. And actually, one good example of this was actually fairly recently, and this came from Apple Intelligence. I opened up my phone and I saw that I had several group chat messages that I had missed. Okay, and I had missed a message or two, and this is just an example here, but I miss a couple messages and I see, okay, baseball game tomorrow from 6:45 to 8:15. Okay. And then there's several confirmations. Okay, little Johnny's excited and can't wait, and all that kind of stuff. And several confirmations. Well, what happened here was the app itself went and summarized all those messages that I missed and then gave me a summarization of that. And so I can basically quickly catch up with the messages just by scanning through this list. And I can know immediately, do I actually need to go and do something here? Okay. And again, this is an example of an AI and an agentic application. Sure, it's probably not doing full tool evaluation, et cetera, but it's using models to do something for me. And it's giving me immediate feedback and value out of this flow. As I was looking at this particular example, I was thinking, well, how easy is it to recreate something like that? And one of the things that I discovered as I was doing that is, well, models are fairly flexible. Okay. I know a lot of times we're chatting or we're actually putting in, again, chatbot messages into our interfaces and sending those, but models are, again, pretty flexible. I can actually give it JSON data and have it do something. In fact, I'm going to do just a little example of that here. I'm going to pull up a little app that I've built that helps just kind of visualize the messages in a stack go into an LLM. And I can give it this system prompt that basically just says, hey, you're a tool that's going to generate summaries for a collection of messages in a group chat. Okay. The goal is to help the reader of the summary know if they need to take immediate action or not. The details of each message and will be conveyed in JSON structure. It's going to provide the name, date, and contents. And here's some rules about what the summarization should look like. Okay. No more than 200 characters. Don't summarize each message individually, but the entire flow of the conversation, so on and so forth. Okay. Now, so what I can do then is I can say, well, hey, let me put basically another user message on the stack. That's the JSON data here. Okay. And looking at this, okay, I see one message. I need the FAQ for the website. Can you make it work? And then, okay, about 2 hours later, are you there? Any updates? And then finally, never mind, we got it. We used the Reddit post. Okay. So I'm going to send these messages to the model. In this case, it's a Gemma 3 model that's just running locally on my machine. And what's going to happen is, again, Gemma's going to process this system prompt, the JSON messages, and I get this response back, this summary. Okay. FAQ needed by end of day, Reddit post used for FAQ creation, issue resolved. Okay. And so my application can do all this behind the scenes. No chatbot is needed to make this flow work. Okay. And again, thinking about this, we can do a lot more with agentic applications once we start thinking about what are other ways that we can trigger these types of these flows. So for event-driven agents, basically defined as agentic applications that are triggered based on external events, not a chat message. Okay. And those external events can be webhooks. They can be system events. A file was created or edited. It can be based on time. So every morning at 9 o'clock, I want to go and run these various tasks that are going to set me up for success for the rest of the day. Okay. And those events then flow into an application to create prompts and then generate some sort of result. Okay. So that's the space we're working in here. Okay. Now let's look at an example of one. The GitHub PR analyzer. Now, why am I thinking about this? Well, I guess it's been about 2 months ago now. At Docker, we had an internal hackathon in which the theme of the hackathon was simply create an agent that helps increase your productivity in a day. Like, okay, that's a pretty broad topic, but I could take that anywhere. And as I started looking around, one of the things that, again, thinking event-driven agents, one of the things that I really wanted to help make better was we have a lot of sample application repositories. Okay. Very simple apps to help containerize or to teach various things, workshops, etc. We have lots of these. And there's an interesting thing that occurs every so often. It's maybe every 2 or 3 weeks, or we have a student that goes through one of these workshops, one of these training materials, and as they complete the work, they submit a PR afterwards, basically saying, "Hey, can here's the work that I did. Okay, so here's the Docker file I made. Here's the website change that I made, et cetera." Um, and while we're really excited that they submitted that PR to us, we can't really accept that PR because it's going to inhibit the ability for the next student to actually complete the workshop. And you can see actually even with this screenshot here, okay, there was a PR that was submitted October 24th, and okay, we're not always super responsive with all these repositories, which is something I can do better on. But on November 6th, we actually responded to it. Okay, so a couple weeks later, hey, thanks for submitting this PR. We're glad you're excited to be learning about Docker. Keep it up. Unfortunately, we're not going to accept this. Okay. So I've been thinking about this space of, is there a way that I can automate this? Can I use models to basically say, hey, a PR was created, and now analyze the PR, determine if it's basically the work that this particular workshop is asking the user to complete? And if so, can we automate creating a comment and closing the PR? Okay. So let's look at what this flow might look like. When a PR is open on GitHub, there's a webhook that gets triggered. Okay. I can register on the other end of that webhook a receiver for my application. Okay. And then that application can use a collection of different tools and agents. And I guess I should back up and say, one of my goals with this hackathon when I was building this was I want to do everything using agents. Okay. And then I'll talk about some of the lessons I learned with that and at the end. But again, the way that this is going to work is the webhook is going to get received, and then I'm going to delegate first off to a sub agent that's going to analyze the PR. Okay. Maybe this agent needs to go get additional details. Okay. What files were changed? What were the details of those files? Does this look like it's actually enhancing the tutorial, or is this looking like it's the output of completing the tutorial? Okay. I want to be able to generate a comment. Okay, so let's personalize it a little bit, or maybe even respond to, hey, we're glad that you submitted a Docker file, and great job learning about how to create container images. But again, we don't want to accept this PR. Okay, so let's generate a comment that reflects a little bit of the types of things that they're working on, and then finally another agent that actually goes and executes things, that posts the comment and then close the PR. Now, a couple of these tools or a couple of these agents are going to need tools to be able to actually go and get additional details from GitHub, post the comment, close the PR, et cetera. Okay. Now, so this is kind of the architecture of this agentic application that we're going to build here. The flow, what it's going to end up looking like, there's just a slightly different representation of what we just saw. Again, the PR will be received. We're going to extract the details from the webhook. We'll analyze the PR, and then there's a decision that needs to be made. Do we actually close it or not? If the agent decides we're not going to close it, then we're just going to stop our flow here. Otherwise, we're going to generate a comment and actually post and close the PR. Okay. All right. So let's get to building here. We're going to start off with the comment generator, because this is the fairly simple one. We're just going to generate a comment. And the goal for this agent, again, generate a comment to post on the PR while closing. The model that we need for this can be a pretty simple one. It's just going to generate some text. Nothing too complicated. Most models can do that these days. The inputs, I need to give it the details of the PR, who is the author, who are we actually addressing in this comment, and then the output's going to be the generated comment. Okay, we don't need any tools, so the flow is fairly simple here. I just need, again, a model that I can use to actually create this comment and go from there. Now, one of the things that Docker has released in the last couple of months is a tool called the Docker Model Runner, which makes it very easy to run models either locally on my machine or out in the cloud, et cetera. But one of the really cool things that the Docker Model Runner provides is the ability to basically treat these models very similar to my container images. So I have a CLI tool that's the CLI commands that lets me pull and run commands, et cetera. And then there's also compose integration where now I can actually define my models directly in my compose file and then inject those into my services. Okay. And so this allows me to, now I can do a Docker compose up and it spins not just my containers, but also the models that are needed there. Okay. So let's get to writing. Okay. What we're going to do is I'm going to specify the model again using Docker compose. We're going to write the agent code and we're going to get this all spun up here. All right. So with that, I'm going to switch over to VS Code. And again, you can use any framework that you want to use. In this case, I'm going to be using the Mostra framework. It's a TypeScript or JavaScript framework, but there's no requirement that this has to work that way. Now, the first thing I'm going to do is I'm going to actually open up my compose file, and I'm going to define the models that we're first going to start off with defining the model. Okay, so we're going to use the Gemma 3 model to generate the comment. Okay, again, it's a fairly small model. It works very quickly, and I can plug that in pretty easily. And then what I'm going to do is I'm going to update my code here to specify that I want the Gemma 3 model. Okay, the endpoint var field here, okay, is let me just write this out and then I'll explain it. Okay, what this is going to do is when compose starts, it's going to define an environment variable, name this, that's going to be injected into the container so that when I connect to the value of this environment variable, it's going to connect to basically the OpenAI endpoint that's going to serve this model. Okay. Now from here, I can run Docker compose up, and then I will have my model. Okay. And then the application running. All right. So what I'm going to do, and actually I'm going to stop that for a second, and I'm going to run this locally. Let's define the comment creator agent. Okay. So make a file, comment creator. And I know I'm copy and pasting, but I'll explain what's going on here. So with the Mostra framework, what allows me to do is I can say, I want to create a new agent. And what's the name of the agent? And then the instructions are basically, what's the system prompt for this particular agent? And let me turn on word wrap so it shows the whole prompt here. Okay. So for this particular agent, I'm saying you're a bot that's being used to create a comment for a pull request in a repository, informing the user the PR is going to be closed. Here's some background. Here's some instructions. Here's some specific details. And at the end of the presentation, I'll share a QR code that links to this repo so you can read through it all and everything too. But again, I'm telling this agent, how should you run? Okay. So I'm going to save this and I'm going to register it with the Mostra framework. Okay. And one of the really cool things that Mostra does is switch over to my browser on localhost 4111. When I'm basically running this in development mode, it gives me a toolbox, a playground that I can interact with the agents directly. So again, I can still see that system prompt that I just defined. And now I can start to actually write messages. Okay, so let's actually test this out. Let me give it a message. I'm just going to copy in a message. Okay, so PR to generate a comment for that will be auto closed. Okay, so I'm going to give it, say, hey, here's the author of the PR, the org, and the PR number. And again, what's going to happen here is this is going to generate a comment using the Gemma 3 model that's running locally on my machine. And I'll jump back to the code to show you how it's connecting to the OpenAI endpoint. But again, here's the comment that it generated for us. Okay, so going back to the code, we talked about the system prompt, but one of the things I didn't talk about was how we're actually connecting to the model. Okay. So one of the cool things about the Docker model runner is it exposes an OpenAI compatible API, which means any tool, in this case Mostra, but it will also work with LangGraph or any other tools that you might be using. I can basically just swap out the base URL to now point to the base URL of Docker model runner. And then as the tooling creates its request and sends it to the OpenAI model, in this case, it's actually not sending it to OpenAI, out on the cloud, but it's staying on my local machine. Okay. In this case, it's actually going to localhost to run. Okay. All right, making sure I got everything. Okay, yep. So we've got our app, we've got our agent. It's using local models. Great. Okay, now let's talk about our next agent, the PR analyzer. Now the PR analyzers needs to do a little bit more work. Okay, we want it to be able to look at the PR and detect, hey, is everything working right? And is this the type of PR that we want to auto close? Okay. And so in this case, the model needs to be a little bit of a smarter model. It needs to be one that can do some reasoning, that can maybe do some tool executions and say, hey, actually, I need some more details. Can you go fetch details about this PR? And then based on the response, um, determine whether the PR should be closed. So we're going to give it some inputs. The output is really going to be, do I recommend this thing being closed? Okay. And I'm going to give it a collection of tools to be able to go get more PR details, even get the files and the diffs for the files that are part of the PR. Now, the question is, where are these tools coming from? And with this being an AI conference, I think most people have probably heard of MCP by this point. But in case you haven't, MCP is a great way to package up the tools and connect them to my application. Okay. And Docker has created an MCP catalog, in which this MCP catalog is a collection of containerized MCP servers, so that I could basically just run an MCP server. I don't have to figure out, okay, this is a UVX MCP server, so I need Python, I need UVX installed. What versions of those things do I need? Are there other system dependencies I might need, et cetera? With them being containerized, you just say, just run it. Okay. And it doesn't matter if it's UVX or MPX or a Golang or Java or whatever. That's the beauty of it being containerized. Okay. And then the MCP gateway provides the ability to easily run these containerized MCP servers. What it provides is the ability to say, hey, I'm going to run this, use the API socket. So it's going to use the Docker socket and credentials and things that are needed there. And here's the servers to expose. And I only want to expose certain tools. And we'll see that here in just a second. Okay. So actually, if I switch over to the MCP catalog, if I just search for GitHub, because that's what we need here, okay, I could see that there's an official GitHub MCP server that has, in this case, 93 tools available for me to use. Okay. And I can see that there's tools related to pull requests down here. So, get pull request, get pull request diff, the files, et cetera. So there's a lot of tools that are available here. I probably don't want to use all of them because 93 tools will really slow down my work and take up a lot of context. Okay. But this looks like a good MCP server for me to use. Okay. So let's get back to our code. We're going to now specify the model. In this case, we're going to use Quinn, a Quinn 3 model for this PR analyzer. We're going to set up the MCP gateway, and then we're going to actually write our code here. Okay, so let's go back to VS Code. I'm going to go to the compose file, and in the compose file, first I'm going to define the Quinn model. And so we'll put that down here. And one of the things I can do with the models, I can specify not just the model, but hey, this particular model is going to need a little bit of additional context size because, again, it's going to be having to get additional details, and that's going to start to fill up our context window fairly quickly. I'm going to connect the model to my, oops, that was the wrong one. Okay, I'm going to connect the Quinn 3 model to my application. All right, great. I've got the model. Now let's connect the MCP server. Right now, the MCP server, as I mentioned just a second ago, I can use an MCP gateway. The Docker MCP gateway, again, allows me to just kind of spin up these containerized MCP servers. I'm going to specify I want to use the GitHub official, and then I've specified only the tools that my application needs to actually use. In this case, I'm going to give it access to git commit, git pull request, the diff files, get the file contents, and then I've gone ahead and added the tools that we'll also need for the last agent as well to actually post the issue and update the pull request to close it. So from here, let's go ahead and I'm going to go ahead and do that. Yep. Okay. Okay. All right. So we've got our Oops. Oh, I forgot one thing I needed to do. This GitHub official MCP server needs a credential. Okay. And I'm going to inject that credential. I have an environment variable file that has a GitHub personal access token. And so what that's going to do is it's going to read this secrets file, inject it into the um, into the MCP gateway, and then it will use that credential to actually communicate with uh, GitHub. Okay. All right. So we've got that started. Hooray. And we should see now. If I do Docker PS, I see the MCP gateway. Hooray. All right. Now I just need to actually write my analyzer. Okay. PR analyzer. Okay. And again, I'm just going to paste this in here. So the system prompt here is saying, again, you're a bot that's going to analyze a pull request for a repository and determine if it can be auto-closed or not. And then again, provides descriptions. Now here's the instructions. And then here's good indicators on when you should reject this thing or when you shouldn't. Okay. So we notice that a lot of times our students that submit PRs, they completely miss the PR description. Okay. So if there's no description of saying what enhancement is this providing, that's a pretty good sign that this should be something that's auto-closed. If the updated files include changes that don't suggest improvement to the tutorial, for example. So again, lots of little things here that help guide the model to know, is this something that should be closed or not? The output that we want is a JSON object that contains, in this case, 2 fields. Okay. Recommended to close, true or false, and then a description on why did the model decide this thing should be closed. Okay. So again, we're telling the model this is what we want to have happen. We connect the model to our OpenAI endpoint. And then the last thing I need to do is actually give it access to the tools. Okay. And so we'll go ahead and do that. MCP gateway. And with the Mastra framework, I can just create an MCP client that will connect to a URL. In this case, it's going to connect to the URL exposed by the MCP gateway. So in this case, it's actually localhost 8811/SSE is where it's running from. Now, actually, one of the things I'll show real quick. Meant to do this a moment ago. Is for those of you that haven't played with the MCP inspector, I can actually use the inspector to inspect again the MCP gateway, and I can list out the tools. And again, I see just the list of tools that are there. And so actually, let's go ahead and ask it, say, all right, let's look at Docker 11 getting welcome to Docker. I think that's a valid PR number. Okay, there we go. And so again, this is validating that the MCP server, everything is working correctly. Again, the gateway is using my credentials. If you haven't used the inspector, it's a fantastic tool, again, to help visualize and see what's going on with your MCP servers, how they're configured, what tools are exposed, et cetera. But also MCP servers can do a lot of other things as well too. So I'm just focusing on the tools capabilities right now. So the last thing I was just going to do was register this with the Mastra framework. And now I can go back and let's go to our agents, our pull request analyzer. And, let's go ahead and make a pull request. I've got a little training repo here that I can just use. And let's just say I'm going to make a Docker file from Nginx, run echo hello world, and we'll just send this to through HTML page. Okay. Sure. That looks like a good commit message. And we're going to create a branch so then we can actually submit a PR for this. Okay. So let's submit a PR. And I'm going to have my agent now analyze this PR. Okay. So let's go in here and say PR to analyze to determine if it can be auto closed. Author, Mike 37, owner, repo, temp training demo, and then PR number, which I already forgot the number, 14. Okay. And so what's going to happen now is, again, we're going to use the local Docker model runner to run Quinn 3, and it has access to all these tools that we see down here. And what we should see is here in just a second, once the model's loaded and it starts processing, okay, yep, I see the request to say, hey, the model needs additional details. Okay, it needs to know about the pull request. So we see the request to run this tool. We see the response that came back from it. The GitHub MCP servers are very, very chatty. And so it takes up a lot of context and sometimes takes a little while for the models to process. But in this case, I get a response that says, yep, we recommend it close. The PR title suggests adding a Docker file for an Nginx container with a hello world page, which aligns with typical student workshop exercises. So again, we're able to test, we're able to validate, cool, this thing actually works. All right, let's continue on. Finally, the last agent, the last step here is let's post the comment. Let's close the PR. Okay. This last one, again, is fairly simple. We just wanted to be able to actually execute tools. But again, since we want to execute tools, we need at least a model that's smart enough to execute tools. And so we'll continue to use our Quinn 3 model. The inputs, we're going to give it the PR to close and the comment details. The output, was it successful or not? And then finally, the tools will need to be able to post comment, update the PR status, okay, which we already added with the MCP gateway. So in this case, we're basically just going to write the code really quickly because it's much of the same process that we did just a moment ago. So I'll call this the PR executor, and I'll paste that in here. The instructions, again, the system prompt, you're a bot that's going to post a comment on pull request. The comment PR details will be provided to you. Here's the steps to complete. And then one of the things that I noticed as I was testing this is sometimes it would, post the comment multiple times. Okay, so I tell the model specifically, you're only to post the comment once, and then don't change any other details of the pull request. I saw a couple times it would do some various things like update the title or description, that kind of stuff. And so again, things that as you test the agents, you'll start to notice the types of behavior that it might do. And so then you can specify those in the prompts. All right, so from there, I'll save this. No, I don't care about the memory. Thank you, Copilot. And then let's go ahead and plug this in. Okay. And again, now I'll have the agent over here, and I can just say PR to close. Well, we'll skip this. We'll just do a full demo here in just a second. But again, it'll follow these instructions. It'll post the comment, close the issue, etc. Okay. Now that we have all the agent code, now how do we actually connect it to the webhook? Now, normally I would deploy this application to a production environment or something like that. But during development and during testing, especially since this was just a hackathon, I wanted to do something that was fairly easy to do and didn't require me to actually deploy anything. And there's a great service called sme.io, which is a webhook payload delivery service. And basically, you can just create a new channel, and then in the settings for the webhook, you basically just connect that channel here. And so what ends up happening is the webhook will go to that SME endpoint, and then in your code base, you can create a client that then basically just gets those messages and then can replay it within your own application. So you don't actually have to have a deployed environment somewhere just to be able to do testing and development. So again, really useful service here. So I use SME to, the PR would go to SME, and then my application would then have a SME client and forward it on to the app itself. And so let's go ahead and plug that in. All right. Fortunately, I've got all the code here, so I'll just uncomment this. But what ends up happening is that the SME client will connect to this endpoint, And as the webhooks are received or are sent from GitHub, they go to this endpoint. The client will also receive it, and then we'll replay it locally to a local webhook endpoint. So I just have a small little express server here that's going to take the webhook, parse the details out of it. So get the PR number, the org, the repo author, just other details. And then what it's going to do is say, hey, Master, I want to get a workflow, and I'll show you where this connects here in just a second. Run this workflow. Okay. And give it, or first get the workflow and then run the workflow with this input data. Okay. So process this PR. And then we'll see what happens. Okay. So let's go ahead and I'll save that. And then let me show the workflow real quick. Okay. Boink. Then I just need to plug in. Yes. Okay. All right. So the way that the workflow, kind of going back to this slide here, we need the agents and the conditional branching and everything. That's where the workflow comes in. Okay. So what we'll see here is I've got a workflow. Here's all the starting schema. Okay. First off, we're going to use basically a step that's going to use the agent, that PR analyzer, to determine can we close. And then based on that, we're going to branch off and say, hey, depending on the output, if it recommended we close, okay, if the recommendation to close is true, then run this next step, and then run the PR execute step. So again, the workflow allows us to do all this branching and conditional logic, connecting all these different agents together. All right. Let's go ahead and kick this off then. And so what we should see now is, let me clear the logs there. I've got the webhooks set to anytime that a PR is created or reopened. So what I'm going to do is I'm going to close this and then reopen it, and we should see the webhook get triggered. So I'm going to click reopen, but before I do that, I'm going to switch to VS Code so we can see the log output here. So reopen. I thought I should have seen the, should see forwarding. Okay, maybe it just didn't pick up that code change. Okay, let me bounce, close the PR, reopen the PR. Okay, there we go. So PR webhook received, okay, for the close. And so it's ignoring it because it's a close. But then when I reopen it, I see another PR webhook show up. We can see it's kicking things off. Okay, we see the first agent that it's going to analyze it. That here's the details to analyze, and then we get the recommended close is true. And so we see that. We then should see the next one where it's going to then use our comment creator. So we see the comment creator go. It's going to generate a comment. We see the response from the comment going now. And then from there, what we should see is the final one where it's actually going to post a comment and close the pull request. And again, it's going to be delegating to the various tools. We see it actually went and fetched GitHub details about the PR. And so now we see pull request is successfully closed. And so actually, let's go back to our browser. Oh, there it is. So we see that the comment was just posted, and the PR was automatically closed for us. Okay. And I see a couple of comments here as well too. What's the best way to secure the webhook endpoints? Now, since this is just a demo here, I don't have the safety in here, but webhooks coming from GitHub can be signed with a secret, or there's a whole credential mechanism. But a lot of times also what you'll do is you can say, hey, I get this PR coming through a webhook. A lot of times applications won't use the data directly from the webhook and say, okay, cool, let me go kick off this workflow. But say, hey, I got a PR open for PR 14 in this case. Let me go get the details of PR 14, and then I'm going to use the results of that API call for the downstream things. And so that further helps protect you from various attacks and whatnot. Um, and as far as there's another question here: safeguards should we put in place so that an event-driven agent doesn't become a rogue actor making unintended repo changes? And that's a great call out. Now, that's why you really want to craft your system prompts to basically say, here are the things that you can analyze. Here are the things to look for. Here are the things that you can and can't do. The executor. These are the specific things that you're going to do. So I'm giving it the specific instructions on what it should and shouldn't do. But even then, I'm also limiting what tools it has access to. So, this particular agent isn't going to have the ability to delete repositories or to create repositories or close issues or anything else. It can only do the things that I'm specifically giving it access to do. And so that kind of multi-tiered approach helps me have a much better and secured agentic environment here. Okay. Now, a couple of things that I want to share, some lessons learned. Okay. Because there's quite a few, right? Now, obviously, there's still gaps in this application, and I see a couple questions of, how do you test? How do you deal with false positives, et cetera? Now, since this was a 24-hour hackathon project, I can only do so much in it. I didn't talk anything about testing, and there's some things that we can do with testing. Okay, I can use frameworks like test containers to actually spin up the models and basically do full integration tests and validate the things that are working. Okay, when it's going to call out to GitHub, maybe instead of talking to the real one, I'm going to mock those responses and kind of control a test environment. Okay, there's also other things that let's see. Let me pull up here. Testing your agents with evals. Again, this is just a capability of the Mostra framework, but a lot of other agentic frameworks have similar types of things where you can put basically evals or evaluators into the code base to say, hey, when this is running, I expect it to have this kind of tone, or it should be similar to this other content. You can do A/B testing with it, and there's a lot of different evaluators and ways to score things. So again, there's a lot of mechanisms that are available to help you test and validate your agentic applications. Obviously, just didn't have the time to go through all that here. The second thing, local models can do great things, but they still have limitations. So again, I'm using Gemma 3, I'm using Quinn models, and I have a fairly good laptop that I'm working with here. But am I going to be able to do full general purpose types of applications and a chatbot that can look up everything and give it 90 tools? No. So again, you really want to think about what are the specific use cases, narrowing down the tools that are available, and then playing with the different models. And that's one of the nice things with it being a compose file. I can just swap out the compose. Let me actually just pull it up here. Okay, I can swap out what model I'm using. Okay, maybe I want to try with a different variant of the Gemma 3 model, maybe that's got fewer parameters or a different quantization, and see, maybe if I use a smaller model, does it go faster and do I still get good results? Okay, so I can experiment fairly quickly. But again, local models, they're not the same as the large GPT models, the Sonnet models, et cetera. And so that's something to recognize. I think we're going to start seeing more fine tuning of models and more kind of, again, application use case specific models starting to be more commonly used. I think right now they're still very niche. As I was talking about earlier, MCP tool granularity. What I mean here is that sometimes the tools can be too granular. One of the problems that I ran into as I was building this and had to figure out the prompts is this executor. Quite often it would post a comment, it would close, and then it would post the comment again. And what I found was, man, the combination of local model and it being separate tool calls, that okay, one tool call to post the comment, another one to close, and then sometimes it would get kind of mixed up of, have I already done this or not? Well, wouldn't it be nice if I just had a single tool that was just add comment and close, and it was all just one trip? Okay, So that's something to think about as you're building your own agentic applications of, hey, are there opportunities to kind of aggregate some tools so that instead of them being too granular, that you can have, one tool that performs multiple functions. Okay. Because what that ends up doing is now instead of multiple trips and more token usage and more cost if you're using remote models, um, more time and resource usage, et cetera. Now it becomes one round trip to just add, comment, and close PR. And so it's faster, it's less usage or less tokens, less costs, et cetera. The other thought that I kept having here was that there are times in which I know that this step is going to be pretty deterministic. Okay, so this executor, for example, when I get here, I know that I'm going to post a comment, I'm going to close the PR. Do I really need an agent and a model to do that workflow? Okay, or could I just say, hey, GitHub API, here's the two API calls that I need to make, and that's just programmatic. Okay, and so as you're building your own agentic applications, there is value in choosing a framework that allows you to connect. Okay, maybe there's some agentic steps here. Okay, but then there's some other steps that are just flat out programmatic. Okay, post a comment, close a PR. It would be much faster than having to use a Quinn model and again do something that is very deterministic, and exactly how it's going to work, and it should work the same way every time. Okay, so to recap here, event-driven agents, they're definitely doable, and they're a great way to automate specific tasks. Again, you want to think about what are the very specific tasks. This case was a PR analyzer. Maybe there's others of, hey, I'm starting my day, and at 9 o'clock every morning, I want it to open up my Jira board and pull out my issues that are assigned to me and help me prioritize them, and then just give me a message. And again, now that's a cron-based, time-driven agentic flow. I don't want to have to open up a chatbot to kick that off. Okay. And so again, the challenge that I extended to you all is think beyond the chatbot. What are the other types of ways that you could build agentic applications to automate some little aspect of either your daily life or something that you're doing for a customer or for a user that's consuming and using part of your applications. Models and agentic applications have a lot of capability, but sometimes we have to think and break that mold in our head of using the chatbot. So with that, I've got a couple QR codes up here. There's the source code repo to this the application. There's a blog post that also walks through this as well too, and then there's the QR codes for the MCP gateway and Docker model runner as well too. So, and I say thank you. Thanks for tuning in. Thanks for watching. It's great to have I've seen a couple questions, and I'll get to maybe one or two of these before we've got a break, and otherwise I'll answer the rest of them just through the Q&A.
Well. Michael, you do have a few minutes. I see some interest there, so let's actually answer. We do have some time actually.
Yeah. Let's see. So let me see where I want to start here. Okay. So there's a question here. If the PR analyzer tool is a black box, how do you detect and deal with false positives? The tool may assume a PR can be closed when it's actually not. And that's something that I've thought about as well too. The last thing I want to have is somebody that's contributing to my application or our repo, and hey, I'm trying to make this better, but you just think I'm a student, and like we don't want to give that experience. So there's a couple things that we can do there. First off, in our system prompt, wrong button there. We want to make sure that we're very explicit in what it's going to take to actually kind of cross the threshold to be auto closed. And so again, it takes a lot of crafting, the prompt engineering here, really getting into, again, what's it take to actually to close it. As far as, sometimes it may still get it wrong. Okay. So what can we do there? Well, for all of these repos, we're also getting email notifications or even Slack notifications in some cases for these issues. And so when new comments are posted, so for example, these are closed and comments are there, we can follow up on it and okay, let's double check, make sure that it wasn't a false positive there. So there's kind of secondary notifications to allow a human to be in a loop. And so would be something else that you want to think about. Another aspect, you can start to use some of the evals that I was talking about earlier to help evaluate, maybe not necessarily the analyzer, but okay, the comment that we generated, does it have the right tone and things that we want there. So there's, again, ways to put a little bit of safety nets throughout the application there. All right. There was a question of how do you recommend handling secrets for agents running inside Docker when they need GitHub tokens or API keys? Yeah, and that's a great question. So going back here, we're using the secrets mechanism within Docker Compose. And so what this is going to do is basically load that as a secret. A secret gets loaded into a container as a tempfs file system. So it's basically a file that's only stored in memory. It's never actually on the disk. And then the gateway can read that file, and then it's going to inject it into the downstream containers. So that credential is never actually sitting in a file somewhere. And we're looking at other mechanisms. In fact, we're actually looking at the entire secrets engine of Docker and containers, and what's the next iteration of that look like? So stay tuned on that. All right. Let's see if we've got time for one more.
Michael, you have a few more minutes.
Okay. Okay.
I see a lot of questions here, so I mean,
okay.
As long as you have time, I think
yeah,
it would be okay.
What time do you want me to be absolutely done by?
Maybe 2:05. I mean, maybe
okay.
4 or 5 more minutes. Should be okay.
Yep, sounds good. So there was a question, what's the name of the webhook service? So it was sme.io or SME. So again, that was the name of the service here. Again, I wouldn't use this for like a production environment but for testing and development, it's a great resource. What are some real world examples where Dockerized MCP agents provide clear benefits over running lightweight scripts or GitHub action workflows? Well, so you're kind of talking about a couple different things there. So a GitHub action workflow, so I guess the question here is, could I basically do this analysis in a workflow? Maybe, maybe not. The challenging part though is I need the model running somewhere, and I can't do all this in a workflow. And so I actually need a deployed application that can respond to these events and do something from there. So typically my GitHub action workflows are going to be around building, testing, validating, the app itself, where then external systems can then respond to these types of things here. All right, and there's a couple questions for links. Yeah, I'll drop the links in the chat right afterwards as well too. So that's a great idea. How can we handle continuing from errors from agentic workflows that were partially successful with one error, for example? Yeah, good question. So there's a couple different mechanisms that you can do here. So a lot of agentic applications will have retries built in. So maybe in a multi-step workflow, if step 1 passed, but step 2 had an error, having it trigger or, okay, let's go ahead and retry that again. That's kind of one of the advantages of some of these workflow systems where I know the input going into a particular step. And so if that step fails, if there's an error for some reason, okay, let's try that step again with the same input and see if we get the same error. If the error is persistent, then okay, yeah, then the application can send notifications or whatever it is that it might need to do from there. But again, having workflow systems that can retry, in a lot of cases, do resolve the situations there. And I think that's most of the questions. I'm scrolling back. Yep, I think that's most of the questions that I see here. So again, if you've got other questions, feel free to reach out to me. I've been getting lots of LinkedIn requests and everything as we've been going throughout it as well too. So feel free to reach out to me on LinkedIn if you've got more questions or think of something else, and I'll be happy to help you out. So thanks all, and hope you have a great rest of your conference.
Thank you so much, Michael. So are we getting closer to cursor writing all the code and
Oh man.
all the pull requests being reviewed by tools like this, and then cursor making adjustments, and then we just eat popcorn?
So my take is I think we're getting closer, but I think there's still a lot of steps to make. So I think for some very specific use cases, yes, but for the general use case, I think we're still a little ways off.
Yeah, it is fascinating how far we have come. Yeah. Okay.
Absolutely.
Thank you so much, Michael. This was very cool. And we are going to take a 5-minute break. We'll come back in 5 minutes.
All righty. Thanks all.
Thank you, Michael.